everybody. In my last video, we discussed what are smart pointers and what are its types: unique pointer, shared pointer, and weak pointer. Today, we will implement our own unique pointer class. Before doing that, let's just do a quick recap what we discussed about unique pointers. So this is the unique pointer class provided by Standard Template Library. We have created a unique pointer of type integer. This is the resource that it has acquired. In unique pointers, calling copy constructor will give you compilation error. Similarly, calling copy operator will also give you compilation error. Why? Because in case of unique pointer, there can be a single resource owner, so these cannot be copied. But move is something that is allowed for unique pointers. Why? Because when we call move on this unique pointer will leave its resource and the same resource is acquired by this unique pointer. We can also call this dereference operator on this unique pointer because we want to use these smart pointers in the same way as we use normal pointers. So with these requirements, let's just start implementing our class. So let's just name our class as unique PTR. STL unique PTR has an underscore. We are using this camel case. We'll create a template class. We'll have this private resource member. Now let's start to implement our functions. So first, let's implement the constructors. So first we have this default constructor. Then we'll have this parameterized constructor. Now we have this copy constructor. And last we have this move constructor. So this is how we implement move constructor using the R-value reference. So in unique pointer, this copy constructor should give you compilation error. So we will simply delete this copy constructor. Now let's just implement our all constructors. For default constructor, we'll simply assign this to null pointer. For parameterized constructor, we will assign this with the incoming value. For this move constructor, first we will assign this with the incoming unique pointers resource. Then we should also take care that this resource should be null. Why? Because in move, this unique pointer should leave its resource. Okay, this was about our constructors. Now let's move to our assignment operator. So this assignment operator should also give you compilation error. So we will simply delete this. But we need to implement our move assignment operator because this operation is supported. So for this assignment also, we will do the same that we have done in the move constructor. But there is one more important step that we need to take care because we can also do something like this. So what will happen if we apply this move on the same resource as we are assigning to. So this will first assign this resource to this current instance, and then it is assigning this resource as null pointer. So ultimately after this line, UP1 will point to null pointer and not the resource. So we should always check that this incoming unique pointers is not the current reference. If this is the case, only then we will apply these. And in the end, we will return this. Now, to support this operation, we need to overload this dereference operator. Now, what if this resource is null? So I'm throwing an exception if this resource is null. Now we should also implement the reset and release functions. So this reset will either assign the new resource to this resource if there is some resource passed to this function. If there is no resource passed to this function, we should assign this to null pointer. So let's have this default value here. Before assigning this new resource, we should also take care of the current resource. So let's check first. If we have some resource, let's just delete this resource first. And then we will assign this new resource. And we can also implement this release function. So this release will first save this resource in a temp variable. It will then assign null pointer to this resource, and then in the end it will return this temp. Now the very important, we need to implement our destructor. So when this unique pointer goes out of scope, then we need to delete the resource that it has acquired. So we will first check whether we have the resource or not. Why? Because it might be possible that this unique pointer has called either release or reset. So if we have the resource, then we will delete it and we'll assign this null pointer. So these are the basic functionalities. You can also implement this operator because right now we have used this on an integer type. We may use this unique pointer for any custom class. So to call any function for that particular class, we need to overload this operation as well. Now let's just try to compile this code. Okay, it has compiled. Now let's just use our own class for this unique PTR. Okay, we have some minor compilation errors. Let's look into these. So here, for this operator, we are returning a reference and not a pointer. Okay, now it's compiling fine. As you can see, it is printing this 5. We can try a few more things, like let's try to uncomment this. As you can see, it's giving now the compilation error which we wanted. Let's just try to print value of UP1 instead of UP3. And since UP1 is not pointing to any resource, this should throw an error. So we'll simply wrap it in a try catch. Okay, let's just uncomment this line. You see, so it is printing this dereferencing null unique pointer. There is also an important function that I have missed, that is the get function. It will simply get this resource. Yes. So yeah, this was all about this unique pointer. If I have missed any function which you want to understand, just mention that in the comment section and I'll be happy to explain that. So in my next video, I'll be discussing how to implement shared pointers in C++. Thank you. Bye.